Today's episode explores groundbreaking advancements in computer vision, focusing on three key areas: three-dimensional reconstruction from limited inputs, real-time processing for time-sensitive applications, and multimodal learning that bridges visual and linguistic understanding. This analysis synthesizes findings from 15 seminal papers published on May 8, 2025, demonstrating how these innovations are reshaping machine perception capabilities. Computer vision represents the artificial intelligence systems that enable machines to interpret visual data with human-like sophistication. This interdisciplinary field combines machine learning, AI, and image processing techniques. Recent advances in deep learning and multimodal models have expanded applications across numerous domains, including autonomous vehicles that perceive their surroundings, medical imaging systems that assist diagnoses, and augmented reality platforms that blend digital content with physical environments. A dominant research theme involves generative models for three-dimensional content creation. The SVAD method developed by Choi and colleagues demonstrates particular innovation, reconstructing fully animatable three-dimensional avatars from single two-dimensional images. This approach utilizes synthetic training data generated by video diffusion models while incorporating an identity preservation module. User studies indicate these avatars achieve 15% higher realism ratings compared to previous methods, potentially revolutionizing virtual try-on systems and personalized gaming experiences. Efficiency optimization for real-time systems constitutes another critical research direction. The PillarMamba architecture, introduced by Zhang's team, demonstrates 40% latency reduction in processing LiDAR point clouds compared to transformer-based approaches. By implementing state-space models inspired by control theory principles, this method maintains accuracy while dramatically improving processing speed, a crucial advancement for autonomous vehicle safety systems requiring instantaneous environmental perception. Multimodal learning research bridges computer vision with natural language processing. The Mogao framework developed by Liao's research team unifies text-to-image and image-to-text generation within a single diffusion transformer architecture. This approach outperforms GPT-4o in benchmark evaluations by enabling context-aware, coherent multimodal generation, a capability with significant implications for developing more intuitive AI-assisted design tools and human-computer interfaces. Key findings across these studies reveal several critical insights. Generative models demonstrate remarkable capability in creating three-dimensional representations from limited inputs. State-space models provide substantial efficiency gains enabling real-time processing applications. Advanced multimodal systems successfully blur traditional boundaries between visual and textual understanding. These technical advancements carry practical significance, particularly in safety-critical domains, where processing efficiency can have life-or-death consequences. Methodologically, several approaches dominate current research. Diffusion models remain prevalent for high-quality generation tasks despite computational intensity. State-space models offer efficient sequence processing alternatives to attention mechanisms. Vision-language pre-training leverages expansive datasets while facing challenges with inherited biases. Physics-informed loss functions and online adaptation techniques address specific limitations, though trade-offs persist regarding model interpretability and catastrophic forgetting during continuous learning. The SVAD paper by Choi and colleagues represents a seminal contribution to single-image three-dimensional reconstruction. Their innovative use of diffusion-generated synthetic training data circumvents traditional multi-view requirements. The architecture's identity preservation module maintains subject fidelity while enabling animation capabilities. With 15% higher realism ratings than prior methods, this technology could significantly reduce production costs in gaming and virtual commerce applications. Liao's Mogao research advances multimodal generation by unifying traditionally separate text-to-image and image-to-text pipelines. The diffusion transformer architecture enables coherent, context-aware outputs that outperform existing systems like GPT-4o. This framework's ability to maintain consistency during interleaved generation tasks establishes new benchmarks for multimodal AI systems and points toward more natural human-machine interaction paradigms. Zhang's PillarMamba architecture addresses critical, real-world requirements for autonomous vehicle perception systems. By combining convolutional layers with state space models, the method achieves 40% faster processing than transformer alternatives, while maintaining accuracy. This hybrid approach effectively captures both local geometric details and global scene context, a technical achievement with direct implications for collision prevention and transportation safety. Future research directions highlight several unresolved challenges. Scaling diffusion models for edge device deployment requires advances in distillation and quantization techniques. Developing modular architectures could improve cross-domain generalization capabilities. The field needs standardized benchmarks for evaluating uncertainty quantification methods. Additional work remains necessary to mitigate biases in multimodal systems and address catastrophic forgetting during continuous online learning scenarios. This presentation was synthesized using advanced AI systems, including GPT DeepSeek for content generation and Deepgram for text-to-speech conversion. Visual components were created with OpenAI's image generation technology. While human experts reviewed the material for accuracy, some potential oversights may remain inherent to automated research synthesis processes. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from arXiv preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights.